Hello girls and boys, welcome to Blackboard Techniques. In this class, we'll be solving the fifth problem in exercise 2.2. If you check out the playlist in English, you'll be able to find out all the previous example problems and exercise problems with solutions. The video link is in the description. Do check it out. It would be helpful for you. Now we can read the question. If P1 power x1 into P2 power x2 into P3 power x3 into P4 power x4 equal 1,13,400, where P1, P2, P3, P4 are primes in ascending order and x1, x2, x3, x4 are integers. Find the value of P1, P2, P3, P4 and x1, x2, x3, x4. This is the question. This question seems complicated, but what is the concept is we have to break this big number into smallest factors. Okay, after finding the factors, we will be able to find out all these values. Okay, the main thing is we are going to find out the factors using L method. Factors of 1,13,400 using L method. If you don't know what is L method, I can give you the description. I can give you the link for that particular class which we had discussed before. So if you check out that video, you can understand what is L method for finding the factors. After checking that video, you'll be able to solve this problem. Now we can see the solution. For the solution, I have written the given information, what is given in the question. Now we have to find out the value of P1, P2, P3, P4 and x1, x2, x3, x4 that had been asked in the question. Okay, what I'm going to do is I'm going to find out the factors of 13,400 using L method. So 1,13,400. I have to take the numbers, take smallest numbers. Okay, since it is the last digit is 0, I am taking 2. That means I have to divide this big number by 2. If I am taking 11 here, if I am taking 11, if it is divided by 2, I'll be getting the quotient is 5, right? 5 into 2, 10. So the remainder is 1. So here we have 13. 13. If I am dividing 13 by 2, I'll be getting 6, right? 6 2s are 12. Remainder is 1. So 1 will be coming here, 14. If I am dividing 14 by 2, I'll be getting 7, right? 7 into 2, 14. So now I can write 0 over here, 00. Then here also we are having last digit as 0. So I can check 2. If I am dividing 5 by 2, I'll be getting 2. 2 2s are 4. The remainder is 1. So 6 is coming here. 16. 16 by 2, I'll be getting 8, right? 8 2s are 16. And then we have 7. If I'm dividing 7 by 2, I'll be getting 3 2s are 6, right? So the quotient is 3 and the remainder is 1. So this one is coming here. So we are having 10 here. So if I'm dividing 10 by 2, I'll be getting 5. And I'm writing this 0 here. Now here also I'm having the last digit is 0. I can take 2 again. If I'm dividing 2 by 2, I'll be getting 1, right? If I'm dividing 8 by 2, I'll be getting 4. If I'm dividing 3 by 2, I'll be getting 1. The remainder is 1. 1 and 5 becomes 15. If you are dividing 15 by 2, I'll be getting 7. 7 2s are 14. Then the 1 will be coming here. 1 and 0 becomes 10. So if I'm dividing 10 by 2, I'll be getting 5, right? So here we are having last digit as 5. So we could not divide this number by 2 because we'll be getting some remainder. If I'm dividing this number by 2, we'll be getting some remainder. So I'm checking with 3. Okay. If I'm dividing 14 by 3, 3 3s are 9, 4 3s are 12. 4 3s are 12. The remainder is 2. 2 and 1 becomes 21. So if I am dividing 21 by 3, I'll be getting 7 as remainder, right? 7 as quotient. So now we are having 7 here. If I am dividing 7 by 3, I'll be getting 2, right? 2 3s are 6. So the remainder is 1. 1 and 5 becomes 15. So if I am dividing 15 by 3, I'll be getting 5, right? And now here we have last digit is 5. So we couldn't divide this number by 2 completely. The concept is whatever number we are taking, that should completely divide this number without leaving the remainder. So I can check with 3 again. If I am dividing 4 by 3, I'll be getting 1. 1 3s are 3, right? The remainder is 1. And 1 and 7 becomes 17. If I am dividing 17 by 3, I'll be getting 5 3s are 15. The remainder is 2, right? 2 and 2 becomes 22. If I am dividing 22 by 3, I'll be getting 7, right? 7 3s are 21. So the remainder is 1. 1 and 5 becomes 15. If I am dividing 15 by 3, I'll be getting 5, right? 5 3s are 15. And now we are having 1575. I need to check with 3. If it is not getting divided completely, we should go for another number. So I'm taking 3 here. 15. 5 3s are 15, right? And 7 is here. If I'm dividing 7 by 3, I'll be getting 2 3s are 6, right? 2 3s are 6. 1 would be the remainder. 1 and 5 becomes 15. So answer is 5. 5 3s are 15, right? Since I have no space here, I can write here. But this is the continuous process. Okay, you have to write it continuously. 525. Here also we are having the last digit as 5. So I can check with 3. If it is not getting divided completely, we should go for another number. So I'm checking 3 now. If I'm dividing 5 by 3, what would be the number questioned? 1 3 is 3. The remainder is 2, right? 2 and 2 becomes 22. So if I'm dividing 22 by 3, we'll be getting 7 3s are 21. The remainder is 1. 1 and 5 becomes 15. 15 divided by 3, 5, right? 5 into 3, 15. And now again I can check 3. 3, if I'm dividing 17 by 3, I'll be getting 5, right? 5 into 3, 15. The remainder is 2. 2 and 5 becomes 25. So I couldn't divide this 25 by 3 completely, right? So I cannot go with 3. So 4 also, first we have to check with 2 and 3. Next 4. 4 also we couldn't take. Why? Because it will not completely divide this number, but completely, right? The 4 also will not completely divide this number. So I can go for 5. Because last digit is 5, so we can go with 5. 4. So if I am dividing 17 by 5, I'll be getting 1 5 is 5, 2 5s are 10, 3 5s are 15, right? 3 5s are 15. The remainder is 2. 2 and 5 becomes 25. So if I am dividing 25 by 5, I'll be getting 5, right? 5 5s are 25. Now I can check 5. If I am taking 3, 3 will not divide this 35 completely. Okay. Now I am checking with 5. If I am dividing 35 by 5, I'll be getting 7, right? 7 into 5, 35. So I can take 7. Now I cannot divide this number by 2 completely. I cannot divide this number by 3 completely. 4 also, 5 I couldn't. But I can go with only one number, that is 7. Okay, here the concept is we have to take the number that should divide this particular number completely without leaving the remainder. So I'm taking 7. If I'm dividing 7 by 7, I'll be getting the quotient as 1, right? 1. So finally we reached the number 1. We can stop. We couldn't go next step because we couldn't. We don't have number. So now whatever number we are having outside is called as factors. So what are the numbers we have gotten as factors? 2, 2, 2, 3, 3, 3, 5, 5, 7. 2, how many times 2 is coming? 2 appears 3 times, 3 appears 4 times, 5 appears 2 times, and 7 appears 1 time. Now we can write the factors of 1,30,400 is 2 into 2 into 2 into 3 into 3 into 3 into 3 into 5 into 5 into 7. Okay, now we can write the answer as 1,13,400 equals, how many times 2 is appearing? 1, 2, 3 times, right? So that we can write 2 power 3. Okay, we can write this 2 as 2 power 3 because this number 2 is appearing 3 times. So 2 power 3 into number 3. How many times number 3 is appearing? 1, 2, 3, 4. 4 times 3 is appearing. So we can write 3 power 4. 3 power 4 into, and next number is 5, right? 5 how many times appearing? 2 times. So we can write 5 power 2. 5 power 2. Then finally we are having 7 only one time. Now we can write, already this is given in the question, this equals this, right? So I can write this equals this. How I can write this? I can compare the both sides. I can write p1 power x1 into p2 power x2, p2 power x2 into p3 power x3 into p4 power x4 equals 2 power 3 into 3 power 4 into 5 power 2 into 7 power 1. We can compare the both sides. In place of p1 we are having 2, right? So we can write p1 equals 2. Why? Because we have to find out the value of p1 x1, p values and x values. That is the question. So we are checking we are comparing both sides. In place of p1 we are having 2, in place of p2. Similarly, in place of x1 we are having 3, right? So we can write x1 equal 3, and in place of p2 we are having 3. So we can write p2 equals 3, and x2, in place of x2 we are having 4. So we can write x2 equals 4. And in place of p3 we are having 5, right? So p3 equals 5, and in place of x3 we are having 2. x3 we are having 2, and finally in place of p4 we are having 7. In place of x4 we are having 1, right? This is the answer. P1, P2, P3, P4, X1, X2, X3, X4. This is all about answer of problem 5 in exercise 2.2. Know the concept of factorization, we can solve this problem easily. If you practice, nothing is complicated. This much I had in this video. I hope this video helpful. If you found this video helpful, hit like button, share it with your friends, and subscribe to the channel Blackboard Techniques for more updates. We'll see you in another video. Until then, Shiny signing off.